Hi, my name is Diego Sanchez, and today we're going to be talking about MIDI. So today we're going to cover what MIDI is, a brief history of the technology, how it works, some basics regarding controller design, and then at the end I'm going to show a short demo that'll hopefully tie together some of the concepts I talked about. So what is MIDI? MIDI stands for Musical Instrument Digital Interface. It's a standardized communications protocol designed to allow computers, musical instruments, and other audio hardware to communicate with one another. It encompasses a set of codes that represent a wide variety of musical parameters such as pitch, dynamics, tempo, and vibrato. And it is currently the industry standard for encoding musical parameters in hardware controller messages. So a brief history on MIDI. MIDI was first developed in the early 80s to standardize the communications protocols between musical hardware components being developed by different manufacturers. Now, this is important because at the time, the industry was experiencing rapid growth and manufacturers needed a way to make sure that their products were compatible with those of other brands. It was necessary because it was getting to a point that if you had one synthesizer, you might need another controller for a different synthesizer or a different drum pad. And you were getting to this point that a good analogy for it would be if you needed a different operating system or a different external hard drive for every application that you wanted to run on your laptop. Partitioning that way and needing all that overhead for every single application just wouldn't make sense. So to address this need, sound engineers from the top musical equipment manufacturers conceptualized the language and a protocol which would allow them to encode musical parameters in a way that was free from any specific operating system or hardware implementation. And this standard first came out in 1983 as a result of joint efforts from top musical equipment manufacturers. So people from Yamaha, from Moog, from Oberheim, all these people from these top musical equipment companies, they got together and they're like, hey, it would be mutually beneficial to all of our companies and to this whole business ecosystem if we just agreed on a way to do it from now on so all of our stuff worked with each other. And that makes sense. But the choices that they made on these original design choices, they have affected the way in which musical instruments have been designed ever since, because they laid the groundwork, they laid the foundations for how things would be developed upon. So how does MIDI work? MIDI works most often in conjunction with a MIDI controller. And I say most often because although it is possible to program MIDI without a controller, as we will see later on, it is most often used with a controller, as that's the way it was first conceptualized and first implemented. So you get yourself a MIDI controller like the one shown down here. And this MIDI controller records musical parameters such as which note's being played, the velocity of a note, and the tempo at which it's being played at. And then it encodes this information into bite-sized chunks at a rate of 31.25 kilobits per second. These messages are then transmitted to a second MIDI-compatible device, whether it's a digital audio workstation or an external synthesizer or drum machine, whatever it is, through a hardwire connection, which then decodes them and interprets the information as it will. Now, it's important to note that MIDI does not record or communicate audio signals in and of themselves. It encodes the way in which something is played. So this means like how hard the keys are pressed, the tempo with which you're playing it, what notes you're being played. It doesn't actually record the audio itself. It's a language much like English or French is a language. It's used to encode a meaning. So a MIDI file is not a playback file format. You can't play it in the same way that you would an MP3 file or a WAV file. It just communicates information in a binary format. So if you were to open a MIDI, it's literally just bits, and that's how it's encoded. So when we're talking about MIDI, we do need to go over some specific principles regarding the controller design. And one of the bigger concepts is obviously the MIDI needs a way to receive input. So whether it's a keyboard like this that has these touch pads and the keys, some pitch knobs, some other filter knobs, or just like another drum pad like this, like the Kai. The MIDI needs a hardware implementation to receive input from the user. It needs some way to receive these parameters. And once it has the parameters, the controller needs a way to transmit that information to the destination. And if we take a look at this diagram right here on the right, we can see how this was initially conceptualized. So you have these ports right here, these inputs and output ports for the MIDI, which are 5-pin DIN ports. And essentially what originally was happening was that the MIDI would receive this information, it would encode it, it would transmit it through these 5-pin DIN ports, which would then go to a MIDI interpreter, which is this little box right here. And this would either go to another MIDI device, or if it was going to a computer, like in this case, this interpreter would encode that information in a way that could be understood by the computer through a USB port, and then it would port it straight to the USB. So as you can see here, the Roland on top has a MIDI input and a MIDI output, and that would need that external interpreter. But as the years went on and these new generations of MIDI controllers came out with improvements and such, eventually what happened is that this interpreter was moved inside of the controllers themselves because it got smaller and it was easier to implement. And so they just made it inside. And so now with these newer ones like this, you do still have the MIDI input right here. And some of them you will have the MIDI output, but more often than not, what you have is this MIDI to USB port right here. That's that MIDI interpreter right there being inside the machine. And just through a special MIDI to USB cable, you can just plug that in directly to your laptop. No need for a secondary interpreter like in this original diagram. So that covers the first part of my presentation. These are my sources. And the second part, I'm gonna set up a short little demo that I'm gonna demonstrate some of the things I talked about and hopefully make it clear some of the ideas I was talking about regarding how the controller itself encodes the information, and then how the destination, in our case, it's gonna be a digital audio workstation on my laptop, how that decodes the information, and then how we can use MIDI files in different ways to make music. So let me go ahead and set that up. All right, so for the demo, the first thing that I want to talk about is the MIDI controller, which I will be doing my demonstration with. So this is my MIDI controller that I have at home. It's a bigger version of that one that I showed in the PowerPoint. And as you can see, this MIDI controller doesn't have the 5-pin DIN input or output jacks. It just has that one USB to MIDI port right here that it transmits information directly to my laptop to. So this is my hardwire connection. It connects directly to my laptop. So let me set this down right here and we can get started. I need to share my screen. All right. So this is my digital audio workstation of choice, Ableton 11. And what this allows me to make music in my laptop, but it also has the drivers for a lot of these MIDI controllers. And so what this will do is it will interpret the information sent from the MIDI controller to the computer, and it will decode it and take the musical parameters and apply them to whatever software instrument I have set up. So I have loaded up a couple of software instruments right here, and we can go ahead and demo how the controller works. So as you can see here, the controller will understand what note is being played. And it will also understand the velocity with which a note is being played, or how hard it's being played. So if I play like a chord like this very softly versus very harshly, the sound will reflect that. The controller knows it has weighted keys
So it understands how hard I'm hitting the key itself, and it encodes that information and it sends it to the digital audio workstation, which then decodes the information and it knows what to do with those musical parameters. So the next part of this example I want to show is what a MIDI file looks like. So this is an example of how a MIDI file is shown in Ableton. And it has these notes drawn in right here. And so imagine we just recorded this on this track right here that has the piano. And so we just wanted to listen to how it sounded on the piano, right? Sound good, sounds fine, but to me it sounds a little harsh. So if I like how the chords sounded and I had it in a MIDI file format, what's really cool is that MIDI allows this parameters to be portable. As MIDI does not record the actual audio signal, I'm not stuck with just this piano sound because I have the MIDI for it. I have the information on the musical parameters of how it was played. So I can port this to another software instrument and have it play the exact same parameters on this other instrument. So we're going to go ahead and put this in a Rhodes, which is a type of synthesizer that came out. I think it was like in the 80s. It has a much softer sound. I enjoy it. So we would have this. So much better in my opinion, but this is a great example of where I can show you what else we can do with MIDI. So I didn't like these notes down here. They sounded a little harsh. Again, let's listen to it. Hear how they're kind of loud? What MIDI allows us to do, again, since it isn't a playback file format, you could actively change the parameters of what is being played back to you, what's being interpreted by the computer. So we can change this MIDI file. Let's move these up an octave. And let's listen to it now. It should be a lot more pleasant. It shouldn't have so much low-end resonance. Much better, right? So one last thing I wanted to talk about was, I talked earlier about how MIDI isn't used most often in conjunction with MIDI controllers, but how it's not always the case. And the reason that it's not always the case is because certain digital audio workstations like Ableton do give you the ability to actively write to a MIDI file format through their program. And so this would be a great example of how you could program MIDI without the use of a controller. So for this track right here, it's just a drum track that I just drew up. And if we listen to it, it's just going to be empty. There's no information. It's an empty MIDI file. And from here, we could just write to it. So what we're going to do is we're going to put a hat hit on every 16th note. I'm going to adjust the velocity of this one so it sounds softer. And so now we have this. That's a bit too fast, see? So good thing that MIDI allows you to undo this. So let's move this hit over here. Much better. And so now MIDI is going to allow us to just actively draw in these patterns however we want it. And so this is a really basic example of how you could use MIDI to just draw in whatever you want instead of having to actively play it. So that about covers the basics of what I wanted to talk about regarding MIDI as both a file format, communications protocol, a hardware and a way of making music. It's just kind of enables you to do a lot of different stuff. It's very portable, and it's a really great technology. Like I really enjoy using it. I make music myself, so I'm a big fan of it. But I hope you guys learned a lot today. And yeah, that's the end of my presentation.